Hi there, and welcome to Tech with Shaping Pixel. In this video, we are diving into part 2 of the AWS Certified Advanced Networking Specialty. The exam is divided into 4 domains: network design, network implementation, network management and operation, and network security, compliance, and governance. Each domain covers specific skills, from designing global architectures to securing network traffic and ensuring compliance. Network design focuses on optimizing user performance, designing DNS solutions, integrating load balancing, and creating routing strategies across multiple AWS accounts and regions. Network implementation tests your ability to connect on-premises networks to AWS using site-to-site VPNs and Direct Connect, and to automate network infrastructure. Network management and operation covers maintaining connectivity, monitoring traffic, and optimizing for performance and cost. Network security, compliance, and governance assesses your ability to secure networks using AWS WAF, Shield, firewalls, and encryption, as well as monitoring and auditing network activity. Apart from this crash course, cover the preparation question and answers from our YouTube channel at Tech with Shaping Pixel. Review the official AWS exam guide, understand each domain's requirements, and practice with AWS networking tools like CloudWatch, VPC Flow Logs, and Route 53. Good luck on your certification journey. Connecting on-premises environments to the AWS cloud. Welcome to this course on connecting on-premises environments to the Amazon Web Services cloud. This course is designed to support your journey toward the AWS Certified Advanced Networking Specialty certification, focusing on essential networking concepts and services. Course objectives. Our main goal is to provide a high-level introduction to the tools, technologies, and services used to connect on-premises environments to the AWS cloud. You will learn about AWS Direct Connect and Virtual Private Networks, or VPNs, and how encryption is used to secure traffic as it moves across these connections. We will also introduce AWS routing fundamentals and industry-standard routing protocols, such as Border Gateway Protocol, or BGP. Key topics covered. Throughout this course, you will explore the integration of AWS networking services, security best practices, and the nuances of hybrid networking architectures. Each concept will be explained and reinforced from the ground up, ensuring you gain a solid understanding. Together with other courses in this learning path, you will cover all the key tools, technologies, and concepts from the AWS Certified Advanced Networking Specialty Exam Guide. Who should take this course? This course is ideal for those with experience designing, implementing, and operating complex AWS and hybrid networking architectures, especially if you are preparing for the AWS Certified Advanced Networking Specialty exam. Many organizations start their cloud journey cautiously, often by expanding storage with Amazon's Simple Storage Service, or S3, to support long-term data retention. This careful approach allows businesses to validate how AWS can address their unique challenges before fully committing to the cloud. Once initial use cases are proven, organizations may deploy Amazon Elastic Compute Cloud, or EC2, instances and look to connect these with their on-premises data centers. This hybrid setup enables EC2 instances to access resources like Active Directory domains, private domain name system zones, and internal databases. To securely connect these environments, companies often use an AWS Site-to-Site Internet Protocol Security, or IPsec, virtual private network tunnel. They can choose between a virtual private gateway, which connects to a single virtual private cloud, or a transit gateway, which links multiple virtual private clouds within a region. While these VPN solutions are quick and easy to set up, they have limitations. Each VPN tunnel supports a maximum bandwidth of 1.25 gigabits per second and relies on the public internet, which can result in unpredictable performance. To overcome these challenges, organizations turn to AWS Direct Connect. This service provides dedicated, high-bandwidth connectivity, ensuring consistent performance for latency-sensitive applications and maximizing the benefits of AWS. AWS Direct Connect offers organizations a dedicated high-speed and low-latency connection to Amazon Web Services by bypassing the public internet. This service is ideal for businesses needing reliable and consistent network performance when accessing AWS resources, but it is not a fully managed end-to-end connectivity solution. When you order AWS Direct Connect, you are granted access to a 1, 10, or 100 gigabits per second network port at a Direct Connect location, also known as a DX location. However, you are responsible for connecting your data center to this port, typically by working with a network partner. Unlike a virtual private network or VPN, Direct Connect requires physical cabling, which can take weeks or months to install. Before ordering, ensure your network supports single-mode fiber and the correct transceivers for your chosen speed. Ports must be manually set to the correct speed and full duplex mode. All devices must support 802.1q VLAN encapsulation, and your router must support Border Gateway Protocol, or BGP, with BGP MD5 authentication. Asynchronous bidirectional forwarding detection, or BFD, is available but must be configured on your network. AWS Direct Connect supports both Internet Protocol version 4 and 6 and allows Ethernet frame sizes up to 9,023 bytes. When considering AWS Direct Connect, one of the first questions that comes up is, how much does it cost? The answer, as with many technology services, is that it depends on several factors. AWS Direct Connect pricing is based on two main elements: port hours and data transfer out, or DTO. Port hours are the amount of time your Direct Connect port is provisioned, similar to how you pay for an on-demand EC2 instance. Even if no data is moving, you are still billed for the port being available. Data transfer out is the total data sent from AWS to external destinations, charged per gigabyte. Pricing varies depending on your AWS region and the specific Direct Connect location you use. To estimate your costs, you can use the AWS pricing calculator. For example, a single 1 gigabit dedicated connection in Northern Virginia running at full utilization costs about $219 per month for port hours. If you transfer 100 terabytes of data out, that adds approximately $2,048 per month. Understanding your application's usage patterns is crucial. Both port hours and data transfer can significantly impact your monthly bill, so careful planning is essential for accurate cost estimation. Many organizations begin their cloud journey with simple solutions like Amazon S3 for backups. But as production workloads move to the cloud, a reliable connection between on-premises data centers and AWS becomes essential. While VPN tunnels using AWS virtual private gateways or transit gateways are quick to set up, they rely on the public internet, which can be unpredictable and limited to 1.25 gigabits per second. AWS Direct Connect solves this by providing a dedicated, high-speed, low-latency connection from your business location to AWS, bypassing the public internet entirely. This setup involves your business site, an AWS region, and a Direct Connect location, which is a regional colocation facility with AWS-managed routers. Before ordering AWS Direct Connect, ensure your network meets several requirements. Use single-mode fiber and appropriate transceivers. Disable auto-negotiation and set full duplex. Support 802.1q VLAN encapsulation, and have a router that supports Border Gateway Protocol, or BGP, with BGP MD5 authentication. Direct Connect also supports asynchronous bidirectional forwarding detection, or BFD, both IP version 4 and IP version 6, and Ethernet frame sizes up to 9023 bytes. AWS Direct Connect costs are based on port hours, which is the time your port is provisioned, and data transfer out, charged per gigabyte. AWS Direct Connect offers a robust, dedicated solution for connecting your data center to AWS, supporting demanding workloads with reliability and speed. To connect your on-premises network to Amazon Web Services using AWS Direct Connect, you need at least one virtual interface, or VIF. A VIF enables Border Gateway Protocol, or BGP, peering between your router and AWS, allowing secure traffic exchange. There are 3 types of VIFs. Public VIFs provide access to AWS public services like Amazon Simple Storage Service and Amazon Simple Notification Service using public IP addresses. Private VIFs connect directly to resources in your Amazon Virtual Private Cloud, or VPC, using private IP addresses. Transit VIFs link multiple VPCs across accounts and regions through a transit gateway and a direct connect gateway. Each VIF requires a name, an owner account, a unique virtual local area network, or VLAN ID, and an address family, either Internet Protocol version 4 or version 6. You must also specify a BGP Autonomous System Number, or ASN, and set a BGP MD5 authentication key for secure connections. Public VIFs are ideal for high-speed access to AWS public services. Private VIFs enable direct connectivity to VPC resources. Transit VIFs simplify complex hybrid cloud networks. Always use clear naming and proper ASN ownership for best results. When setting up AWS Direct Connect, or DX, customers often wonder if they can request multiple connections in one or more DX locations to boost resiliency. The answer is yes, and AWS has made this process straightforward. Ordering connections and the Resiliency Toolkit. Using the AWS Management Console, customers can choose between Classic and Connection Wizard ordering types. The Connection Wizard launches the AWS Direct Connect Resiliency Toolkit, which helps organizations design resilient architectures that align with their Service Level Agreement, or SLA, objectives. Resiliency Models Explained. The Resiliency Toolkit offers 3 models: maximum resiliency, which creates multiple DX connections in multiple locations; high resiliency, which creates a single DX connection in multiple locations; and development and test, which creates multiple DX connections in a single location. Understanding link aggregation groups, or lags. Multiple DX connections within one location can be grouped as a link aggregation group, or lag. Lags combine the bandwidth of several physical connections, so 4 1-gigabit connections act as a single 4-gigabit connection. Key lag considerations and limitations. All connections in a lag must be the same speed and in the same location. Lags improve performance and provide some resiliency, but do not protect against an entire DX location failure. Since November 2018, the AWS Transit Gateway, or TGW, has transformed how organizations connect and scale their cloud networks. But what makes it so essential for modern AWS environments? Before Transit Gateway, connecting virtual private clouds, or VPCs, relied on VPC peering. This created one-to-one non-transitive links. For example, VPC A could talk to VPC B and VPC C, but B and C could not communicate directly without their own connection. As networks grew, managing countless peering connections became complex and unsustainable. The AWS Transit Gateway introduced a hub-and-spoke model, acting as a central hub for routing traffic between VPCs, on-premises data centers, and remote offices. This architecture simplifies network management and supports connections across multiple AWS accounts and regions. Transit gateway networks are encrypted and do not traverse the public internet. Each transit gateway supports up to 5,000 attachments and 50 peering connections. With Direct Connect and Transit Virtual Interfaces, or VIFs, organizations can securely link on-premises networks to AWS, even across regions. Imagine 3 data centers, each using Direct Connect and Transit VIFs, all communicating seamlessly with AWS resources in any region through the Transit Gateway network. AWS Direct Connect is a dedicated network service that links your on-premises environment directly to Amazon Web Services, or AWS. This connection offers consistent, low-latency performance and enhanced security compared to standard internet connections. To get started, request a Direct Connect connection at an AWS Direct Connect location. AWS allocates support, and you complete a Letter of Authorization Customer Facility Access Form, or LOA-CFA. This form allows support staff to connect your equipment to the AWS port, establishing physical connectivity. Once connected, you must create at least one virtual interface, or VIF. A VIF enables Border Gateway Protocol, or BGP, peering between your router and AWS. There are 3 types: public, private, and transit, each supporting different AWS resources and network architectures. For advanced setups, the AWS Direct Connect Resiliency Toolkit offers models like Maximum Resiliency and High Resiliency. Link aggregation groups, or LAGs, combine multiple connections for greater bandwidth and performance, but do not protect against entire location failures. The AWS Transit Gateway simplifies global network management with the hub-and-spoke model. Each transit VIF supports up to 3 transit gateways, and a single Direct Connect can support up to 50 public and private VIFs, enabling scalable, flexible connectivity across regions. This course introduces you to the IPsec Protocol Suite, a foundational technology for securing network communications. You will learn what IPsec is, why it is important, and how it enhances both networking and security in modern environments. We will break down the individual components of IPsec, including authentication headers, encapsulating security payloads, and security associations. The course covers Internet Key Exchange, or IKE, Phase 1 and Phase 2, as well as the differences between transport mode and tunnel mode, ensuring you understand each element's role. Explore real-world scenarios where IPsec is especially useful, such as connecting remote networks securely. We will also discuss the limitations of IPsec, highlighting potential issues and considerations to keep in mind when deploying these tunnels. Discover how Amazon Web Services, or AWS, implements IPsec. You will be introduced to key Virtual Private Cloud, or VPC, components like the Virtual Private Gateway, Customer Gateway, and VPN connection, and see how they work together. Amazon Web Services, or AWS, lets you securely extend your on-premises network into the cloud using a Virtual Private Cloud, or VPC, and an IPsec VPN connection. This setup protects your data as it travels between your corporate network and AWS. IPsec, which stands for Internet Protocol Security, is a framework of protocols that ensures data confidentiality, integrity, and authentication as it moves across networks. It operates at the network layer, making it transparent to applications and requiring no changes to your software. To connect your network to AWS, you deploy a virtual private gateway on the AWS side and a customer gateway on your side. Each VPN connection creates two redundant IPsec tunnels for high availability, automatically routing traffic if one tunnel goes down. IPsec uses two main protocols: Authentication Header, or AH, for authentication and integrity, and Encapsulating Security Payload, or ESP, for encryption and authentication. Encryption algorithms like AES and hashing algorithms like SHA provide robust security for your data in transit. AWS VPNs are quick to set up and cost 5 cents per connection hour, plus data transfer fees. However, they only support tunnel mode and do not support IPv6 traffic, so consider your bandwidth and protocol needs before deploying. When connecting your office network to Amazon Web Services or AWS, keeping your data secure as it travels is essential. Let us break down the encapsulation protocols that protect your information during hybrid network connectivity. You can connect to AWS using AWS-managed site-to-site virtual private networks, or VPNs, customer-managed site-to-site VPNs, and AWS Direct Connect. No matter which method you choose, your data must be protected by strong authentication, integrity checks, and encryption. AWS-managed VPNs use pre-shared keys or digital certificates for authentication, hashing algorithms like the Secure Hash algorithm for integrity, and Internet Protocol Security, or IPsec, for encryption. AWS recommends managed VPNs, but customer-managed VPNs allow you to use custom algorithms. IPsec is an open standard in the Internet Protocol version 4 suite. It secures AWS-managed VPNs using protocols like authentication headers for data integrity, encapsulating security payload for confidentiality, and Internet Security Association and Key Management Protocol for key exchange. Two endpoints negotiate security settings in two phases using Internet Key Exchange, or IKE. AWS Direct Connect does not encrypt traffic by default. To secure data, you can run a VPN over Direct Connect or enable MACsec, known as MACsec. Understanding these protocols ensures your data remains confidential, integral, and authenticated as it moves between your network and AWS. Encryption is a key part of securing AWS-managed site-to-site virtual private networks, or VPNs. To set up a VPN, you need a virtual private gateway, or transit gateway, a customer gateway, and a VPN connection. During VPN connection setup, you configure Internet Protocol Security, or IPsec settings. AWS automatically creates two IPsec tunnels, each with customizable encryption options. You can select Phase 1 and Phase 2 encryption algorithms like Advanced Encryption Standard 256 or AES 256 and remove others to enforce strict protocols. Both ends of the VPN must support the same encryption protocol for a successful connection. You also choose integrity algorithms and Diffie-Hellman groupings for secure key exchange. Diffie-Hellman allows keys to be negotiated during session setup, and higher group numbers mean stronger encryption. You can repeat these configurations for Tunnel 2, giving you full control over your VPN's security. After configuring both tunnels, you can download a configuration file tailored to your on-premises device, such as those from Cisco systems. This file contains all necessary IPsec details, ensuring your site-to-site VPN is secure and ready to use. When using AWS Direct Connect, it is important to remember that, unlike site-to-site VPN connections, Direct Connect does not encrypt your traffic by default. If you need encryption, you have two main options. The first option is MACsec, or MAC Security. MACsec provides confidentiality, integrity, and origin authenticity for your data. However, MACsec is only available for dedicated direct connect connections at either 10 gigabits per second or 100 gigabits per second. It is not supported on hosted or 1 gigabit per second connections. You will also need compatible on-premises devices and support from your last mile provider. MACsec operates at Layer 2 and uses hardware encryption, which means you get near-line rate speeds and full bandwidth. The second option is to enable a VPN connection over your Direct Connect link. This uses a public virtual interface, or VIF, to connect to AWS public endpoints. You then create a VPN connection with your AWS Virtual Private Gateway or Transit Gateway, combining the security of IPsec with the low latency and high bandwidth of Direct Connect. Remember, MACsec is faster than IPsec and allows full bandwidth, while VPNs offer encryption for all Direct Connect types. Choose the method that best fits your security and performance needs. When you create a virtual private cloud or VPC in Amazon Web Services, an implicit router is automatically set up for you. This router connects to each subnet using the first IP address of the subnet, even though you cannot see it directly. Each VPC comes with a default routing table. This table includes a local route, which cannot be changed or deleted. The local route allows all resources within the VPC, such as EC2 instances in different subnets, to communicate with each other using the VPC's assigned IPv4 CIDR block, like 10.0.0.0.0/16. To enable EC2 instances in public subnets to access the Internet, you must attach an Internet gateway to your VPC. Then, update the routing table to add a default route, 0.0.0.0/0, pointing to the Internet gateway. This sends all non-local traffic to the Internet. For private subnets, a NAT gateway is used. Deploy the NAT gateway in a public subnet, associate private subnets with a new routing table, and add a default route to the NAT gateway. This allows private instances to access the Internet securely. Every VPC has a main route table, which new subnets use by default. It is best practice to keep only the local route here. For IPv6 traffic from private subnets, use an egress-only Internet gateway, which works like a NAT gateway, but for IPv6 addresses. Let us break down static and dynamic routing in Amazon Web Services, or AWS, and see how they help connect your on-premise networks to the cloud. With static routing, you manually update routing tables with every network route. If you add a new network, you must enter its details yourself. This approach gives you control, but it is time-consuming and can be error-prone, especially as your network grows. Dynamic routing uses protocols that automatically exchange network information between routers. In AWS, the Border Gateway Protocol, or BGP, is used for dynamic routing. BGP enables routers to share updates, so when your network changes, routes are updated automatically. Your on-premise routers must support BGP if you want dynamic routing with AWS. Organizations often use hybrid environments, combining on-premise and AWS resources. AWS offers site-to-site VPNs and Direct Connect for hybrid connectivity. Site-to-site VPNs support both static and dynamic routing, while Direct Connect requires dynamic routing. Enabling route propagation in AWS route tables allows static prefixes from VPN connections to be written automatically, simplifying management even with static routing. Choose static routing for manual control or dynamic routing with BGP for automation and scalability in your AWS hybrid network. With static routing, you manually update routing tables with every network route. If you add a new network, You must enter its details yourself. This approach gives you control, but it is time-consuming and can be error-prone, especially as your network grows. Dynamic routing uses protocols that automatically exchange network information between routers. In AWS, the Border Gateway Protocol, or BGP, is used for dynamic routing. BGP enables routers to share updates, so when your network changes, routes are updated automatically. Your on-premise routers must support BGP if you want dynamic routing with AWS. Organizations often use hybrid environments, combining on-premise and AWS resources. AWS offers site-to-site VPNs and Direct Connect for hybrid connectivity. Site-to-site VPNs support both static and dynamic routing, while Direct Connect requires dynamic routing. Enabling route propagation in AWS route tables allows static prefixes from VPN connections to be written automatically, simplifying management even with static routing. Choose static routing for manual control, or dynamic routing with BGP for automation and scalability in your AWS hybrid network. Navigating AWS networking can be complex, especially when connecting multiple virtual private clouds, or VPCs, and on-premises networks. Each VPC is isolated by default, so connecting them securely requires extra steps. While VPC peering and VPNs are common solutions, they become difficult to manage as the number of networks grows. For example, connecting 5 VPCs directly would require 10 separate peering connections, quickly increasing complexity. AWS Transit Gateway is Amazon's answer to this challenge. Acting as a regional network transit hub, it lets you interconnect hundreds of VPCs and on-premises networks without the hassle of managing countless individual connections. Transit Gateway is a managed service, so AWS handles scaling and infrastructure. You attach VPCs, VPNs, or Direct Connect gateways to it and use route tables to control traffic flow. It operates at Layer 3, routing packets based on destination IP addresses. Transit Gateway simplifies network architecture, supports multiple route tables for flexible traffic control, and scales automatically. However, there are limits. 5 transit gateways per region, 5 attachments per VPC, and a maximum bandwidth of 50 gigabits per second per connection.